Thanks, Phil. Okay, good. It seems like I've got control back. Today I'm going to talk to you about 7 years of data I've been collecting on changes in coral assemblages in Aceh, Indonesia. During those 7 years, there's been 2 acute disturbance events. There was the Indian Ocean tsunami in December 2004, and then in May this year, there's been a mass bleaching event. And a bleaching event that I think will rival the mass bleaching of 1998, so it's a big disturbance. So I'm going to describe the effect of these disturbances on the reefs and talk a little bit about the current potential for these reefs to recover. So I've been visiting Aceh for quite a long time, almost as long as Gary's been in the Philippines, unfortunately, in my early trips, I didn't have my transect tape with me. And so it wasn't until 2003 when, as part of a much larger project looking at patterns of coral reproduction in Indonesia, that I did visit these islands in northern Aceh with my transect tape. So in between cracking colonies to determine their reproductive condition, I laid down some line intercept transects at about 3 different sites on these islands in Pulau Aceh. So when the Indian Ocean tsunami hit on the 26th of December in 2004, I realised that I had my hands on some data that could answer a lot of questions about the effect of tsunamis on reefs, and indeed there's very little work that had ever been done on that. Have I got the mouse? No, I don't. Oop. Yeah, I'll go back to the pointer. Okay, so I'll go back to this slide, hopefully. Right, so this shows the progress of the Indian Ocean tsunami across the Indian Ocean. So the earthquake that generated the tsunami occurred about 200 kilometres south of the northern tip of Sumatra, which is where our study sites were. The colours on the graph show the wave height at particular positions as it progressed across the Indian Ocean. So you can see that in Sumatra, the wave height here is estimated to be about 17 metres when it hit the coast. At the sites that I visited, the wave height was varied somewhere between 5 metres and 20 metres. In fact, run-up in some of these areas was as much as 50 metres, so this was not a trivial event. This is just a closer look at the study sites. I had the 3 study sites that I had from 2003 were concentrated on Pulau Aceh, but with the team from WCS in Indonesia, we chartered a boat and we extended the surveys to get a feel for exactly what the tsunami had done to the reefs in the area. And so there's sort of 2 geographic locations here. There's Pulau Aceh and then this other group of islands across to the west called Pulau Aceh. So 15 sites in total. At each of these sites I ran line intercept transects. But first I'll show you the effect of the tsunami on the 3 sites that I had estimated coral assemblage structure in Pulau Aceh. So what this shows, on the x-axis I've got 10 different morphological categories of scleractinian corals. The first 4 Acropora, morphological categories of Acropora, so you can see that these reefs were Acropora dominated. Percent cover is the metric, and the black bars are March 2003, the white bars March 2005. So you can see that at these 3 sites there was very little change in the assemblage structure. Some taxa increased in abundance, some declined, but there was no major change. This is nothing different than you would expect to see in the intervening 2 years. This is a photograph of Rubiah Sea Garden, one of the study sites, in March 2003. Acropora dominated, lots of tables and staghorns. That's virtually the same spot in 2005. So as you can see, there's been absolutely no change in that coral assemblage. The wave height at this point was at least 5 metres, so again, not as large as the wave got, but still not at all a trivial event. We did see some tsunami damage. This is a Porites bommy that's been washed up onto the beach at one of our sites in Pulau Aceh. It's probably about 4 metres in diameter. And again, here's that same beach looking at a different angle, and you can see a series of large Parietes bommies there. So the general trend that we saw was that where corals were attached, so in the shallow water, on reef, Acropora, they stayed attached. The only habitats where we picked up any damage were those habitats where corals grow in soft sediments. So most Parietes bommies just sit in the sand, in the lagoon and on the sands off the reef. The tsunami came along, scoured the sand from underneath them, picked them up and deposited them on the land. So anything that was attached remained attached, despite the wave being, in these locations being 10 metres or more. The other thing that we did see at these 15 study sites was quite a dramatic contrast in terms of the health of the reefs. So once again, these are the percent cover on 10 random line intercept transects at each of 15 sites. The first 4 sites are in Pulau Aceh, the next sites are in Pulau Weh. And I've coloured the bars according to the management regime that was in place at those particular sites. So you can see that the sites on Pulau Weh were in fantastic condition, cover ranging from 40 up to 80%. 2 types of management regime on the island. There was a tourist reserve, and there was also the system, the Acehese customary system called Pangli Melaut. This is a really interesting system. We're looking into it in much more detail. It's been in place since the 18th century. It works mainly by minimising conflict amongst fishermen, and the way they do that is to minimise the use of gears that cause conflict, in particular nets. There's a lot of fights over which fish to access, and so on the island in Pulau Weh, they have, at most of the sites, they've banned the use of nets which destroy the habitat. On Pulau Aceh, here we've marked it as open access, which is not strictly accurate. As we got to know the area more thoroughly, in effect, all areas of the marine realm are governed by the Pangli Melaut system. It's just that in some situations, in particular on Pulau Aceh, the system had broken down. And what we think had been occurring there was that bombing had been continuing, other destructive fishing practices such as cyanide fishing, nets, all the things that had been effectively managed in Pulau Weh had been allowed to continue in Pulau Aceh, and so that is what had caused the damage at these sites. So we're very confident this was not tsunami damage. The corals that we saw at these sites where cover was low had been dead for ages. This is a colony of Heliopora, the blue coral. It stays blue for a long time after being dead, and you can see here that it's brown and it's eroded. The damage we saw had been in place for a long time. So just to summarise, the shallow water corals largely unaffected, and what damage we did see was trivial compared to the pre-existing damage to reefs. And as I say, even those big massive Parietes colonies that were washed up onto the shore, most of them were already dead. While the damage underwater was nothing major, and again, most of the other studies that have looked at the tsunami influence on reefs have backed up our findings. On land, it was a very different picture. And so this is a satellite image of Pulau Aceh, taken, I think, about a month or two after the tsunami, and all those sort of brown strips are the areas where the tsunami has scoured all the vegetation away. So in effect, everything beneath about 10 metres was completely cleared away. And that is where everyone lived. That's where they had their fields, that's where they had their jetties. So the population of this island before the tsunami hit was about 10,000. 6,000 of those people were killed, and the remaining 4,000 left the island very shortly thereafter. All the infrastructure was destroyed, and so they were evacuated to the mainland, where they lived in refugee camps for up to 2 years. So, people are starting to trickle back. So overnight, every type of human activity on this island ceased. Agriculture stopped, no sewerage, not much fishing, because the people are still coming from elsewhere, land clearing. So all the typical human impacts we think of as damaging to reefs stopped virtually overnight. This is just a few photographs from the villages on land. This is Lampuyang. There wasn't a building standing. This is where the fishing fleet ended up. I'm standing here about 200 metres away from the harbour, probably about 15 metres above sea level, and there's one of the fishing boats. Again, the place was a complete mess. The only thing they had cleared away, thankfully, was the bodies. So what happens to corals when you take the humans out of the situation? We went back, we've been going back annually, but this data is from my last trip there in February 2009. And what we saw was some absolutely spectacular growth of reefs in these areas that had been completely denuded of coral in 2005. So these first 4 sites on the x-axis are the sites on Pulau Aceh, and you can see that the coral cover here has gone from 8% up to about 34%. So we saw 30 to 400% increases in coral cover. At all these sites it's increased. And I'll show you some photos. It really was quite spectacular. In Pulau Aceh, the destruction on land was much less on that island, probably due to the topography of the island itself. But the system on Pulau Aceh remained intact, and so the reefs are still remarkably healthy. The only one spot is here at Batee Meuronron, and I'll show you a bit later, where that is a spot outbreak of crown of thorns has caused that decrease. So just looking at those sites in a little bit more detail, this is coral cover by various categories of scleractinian corals, and so you can see that in 2005 there was virtually nothing there. In 2009 you can see that there's 15% cover of Corymbos Acropora and 30% cover of Postlepora. So there was a dramatic recruitment event, and then growth of these colonies has produced these fantastic reefs. So that's a shot of that site in 2005, and that's what it looked like in 2009. So these extraordinary, vibrant fields of reef. Yes, and just another shot of the reef in 2009. Again, here's just another one of the sites in a little bit more detail, Pasi Janeng. It was dominated by Millepora in 2005. In 2009, again, we've seen recruitment of a number of different species, mainly Acroporas and Postleporids. This is the community structure dominated by Millepora in 2005. This is actually 2009. So this is the recruitment of Postleporids and Acroporas in 2009. This is the reef slope in 2005, and you can see it was just a rubble bed. Again, I think this is probably good evidence of bombing that had been going on in the islands. And you can see that those rubble beds are now being colonised by mainly Acropora and Postlepora. So, spectacular recovery of these reefs. This is just the one site where on Pulau Aceh where we've seen a decline in coral cover. Again, you can see that it's mainly the tabula and the encrusting Acropora that have disappeared. These are the preferred prey of the crown of thorns. This is the site in 2005. This is it in 2009. So there's an Acropora table that's been gobbled by crown of thorns, and there are the culprits. And most of the sites that I visit in Indonesia, crown of thorns is probably the major agent of coral mortality. Okay, and that takes us to about May this year, when the waters in the Western Indian Ocean in particular and in the Andaman Sea started heating up. So this is a figure from NOAA's website. It's dated the 6th of July. And it shows the cumulative, this is the degree heating weeks. And so the areas in green and yellow are somewhere between 7 and 10 degrees of heating weeks. So this is a really major thermal anomaly, and you can see it's over quite a large spatial scale. These sorts of values you would expect to see bleaching, and indeed that's what happened early May. My colleagues in Indonesia let me know that the bleaching was happening, and so we organised to go over and have a look. And so we did some surveys at a number of different sites. So this is 5 sites. I mainly concentrated on the Acropora. I classified them into morphological groups, and we scored them as one of 4 bleaching categories. Green is healthy, black is dead. That's probably all you need to know. And you can see that most of these corals were dead. The overall mortality of the Acropora was about 80%. At some sites, such as the Rubiah Channel, we've recorded 100% of the tabular corals dying. These are just some pictures, show you the course of the event. In April, a nice healthy reef. In May, it's bleached. In July, it's dead. Again, just some photos of this. Again, this is a new reef. This reef had essentially just popped up in front of one of the beaches on Pulau Aceh since 2005, and that's what it's looking like now. Again, high cover corymbose corals and very high mortality of all of them. This is a species that I believe new to science. I haven't seen it anywhere other than Pulau Aceh. And yeah, I'd be very surprised if I'll be able to find any more of this. So this will be the holotype, but I don't think there'll be a paratype. It's an area that hasn't been visited by taxonomists. Coral taxonomist Jerry Allen spent some time there and I think described 3 to 6 new species of gobies. So it's really quite a tragedy that this event's come along, because it's as big as those photos Yossi was showing us earlier of the bleaching in Okinawa, where overall 80% of the colonies died. So we'll be going back at the beginning of next year to get the final estimates on how bad it's been. There's another new species. Again, just putting that back up to let you know the scale of this event. The hot water thermal anomaly was right the way through the Indian Ocean. It will rival the 1998 bleaching event in terms of the scale and the severity. So it's a major event. Okay, just a quick summary. The tsunami itself did very little damage. Indeed, indirectly, it probably helped the reef by reducing the destructive human activities. It's an interesting system in Aceh. There's a very effective customary management. It's been very effective at the local scale, but of course, what the bleaching event shows is that you can't climate-proof reefs, and this is an event that's occurring at a much larger scale, and the only way we're going to address that is to act on a global scale. And just finally, again, yes, bleaching in the Andaman Sea this event is likely to be as big as 1998. Now, I'll just finish with one interesting observation of James Guest in Singapore. Now, as Yossi was talking about, bleaching events typically have winners and losers, and that is consistent over a wide geographic scale. In Yossi's event in Okinawa and on the Great Barrier Reef, it's typically the Acropora, and exactly as I've shown you in Aceh, that suffer, and it's the parietes that typically do well out of these bleaching events. But what these 3 photographs show is very healthy Acropora colonies right next to bleached favids and parietes. Now, what I think what has happened here is that in 1998, Singapore was badly affected by the bleaching. And it's tempting to think that this might be some sort of evidence of acclimation or adaptation. So this was a site that was hit by the bleaching in 1998. The thermally tolerant species, the thermally susceptible genets have been killed, and so we've seen the natural selection and evolution of thermal tolerance. So I thought I'd just end on a positive note there, and thank you very much.